Alright, welcome back to another installment of Math with Medina. Today we're going to be looking at solving equations by using multiplication and division. So a real quick refresher, that really an important thing we're focusing on right now is this idea of inverse operations. And that's looking at two operations that undo each other. And down here we have examples of the two inverse operation relationships, that addition and subtraction undo one another, and multiplication and division undo one another. Alright, so from here, let's look at a couple of practice problems. So first things first, we're looking at our problem here, which is a divided by 2 equals negative 8. And what this is asking me in terms of mental math is, remember back in 2.4, the question, what number divided by 2 equals negative 8? And we'll get back to answering that here in a second. But as I look at this problem, I noted that something's being divided. So in order to solve this problem, we're actually going to need to use the inverse operation, or we're going to solve it by using multiplication. So back to our mental math question. What number divided by 2 equals negative 8? And I'd be willing to guess that most of us know it's going to be that the number is 16, and because our result is negative, it would have to be negative 16. And as always, we need to check our answer. So we're going to copy down the original equation. A divided by 2 equals negative 8. And then we're going to put in our solution, which we got was negative 16. And negative 16 divided by 2 equals negative 8, which tells us that our solution was a pretty darn good answer. Now, here's the thing with that. Mental math, again, is just making a very educated guess. But with showing our steps, we're actually going to be able to defend mathematically what it is we're doing. So, in order to do that, we write down our original equation. And from there, I need to get rid of the 2. So I'm going to ask myself the question, over here, what is that 2 doing? I can see again that it's dividing. So the opposite or inverse operation would be multiplying by 2 on both sides. So remember we talked about, it's really important that we have 2 separate sides to our equation. So if I do something on one side, like multiply by 2, it's important I do the exact same thing on the other. And when I multiply and divide by the same value, those cancel out, which leaves us with a all by itself equals, and negative 8 times 2 would give us negative 16. And remember, we always need to check our answer. So we rewrite our original equation, a divided by 2 equals negative 8, and now we're going to substitute in our value for a. So notice I left a all by itself, goes right up here, negative 16. Negative 16 divided by 2 equals negative 8, and negative 8 once we evaluate both sides. And that gives us a smiley face of knowing that this is a true statement. And if it's a true statement, then that tells us that we got our correct solution. So if you notice, whether using mental math or showing our steps, we came up with the same result. But it's really important long term that we move away from mental math and we really start looking at this process of showing our steps. Alright, so I'm going to give you a problem to practice on your own here using the multiplication property of equality. And remember, that phrase, multiplication property of equality, just says really, it's the rule about multiplying on both sides to keep it equal. Alright, so go and pause the video here, go through and solve for b and using the steps. And then after you've done that, make sure you prove your answer and come back and check your answer. Alright, and to do things a little differently here, I actually have all my work hidden behind a revealer. So I'm going to uncover first the steps I did to solve the equation. So you can see here that we started out and we multiplied both sides by 3, because I saw that b was being divided by 3. And remember that if you multiply and divide by the exact same value, those cancel out, so we can cross them out, leaving us with just b all by itself on the left side. And on the right side, 9 times 3 would give us 27. So this is going to be our solution, that b equals 27. But we need to always double check our answer. So then we go back to the other side of things and we take a look and we check our answer. We rewrite the original equation exactly how we started. Nothing's changed. Then we substitute in our solution, which we did right here. And 27 divided by 3 equals 9, which most of us might say, well, I know that that's true, but remember, it's important that we evaluate it to get to our true statement. And if we can say it's true, then what we're really saying is it's true that b equals 27. All right, so that's using the multiplication property of addition, that idea of multiplying on both sides to keep our equation equal. And the second part of things today we're going to look at is the division property of equality. So let's go on and take a look at that. So just a reminder that because I see there's multiplication between the 3 and the b, we're going to go ahead and use division to solve our problem. So I start out with mental math, and I see 3 times b equals 21. What the question this is really asking us then is, it's asking us the question, what multiplied by 3 equals 21? And I'd be willing to bet most of us know that the number is 7. But we need to make sure we prove that. So we recopy our problem to prove it. 3 times b equals 21. 3 times whatever our solution is, which in this case we got was 7 equals 21, and 21 equals 21. So at this point we can be pretty confident we think we know that we're right. But it's really important long term that we can move away again. We want to move away from mental math and work towards showing our steps for all that we do. Because down the road in the next section, it's going to be important that we can do multiple steps all at one time. All right, so we start out here, we recopy down the equation exactly like it is. 3b equals 21. We're going to go ahead and divide both sides by 3. And when I say both sides, remember that just in my head or even on paper, I'm reminding myself that I'm dividing it, write down the equal sign to 2 separate sides to my equation. And I would get b equals 21 divided by 3 would give us 7. So I can see b equals 7. Now, just like we predicted earlier with our mental math, remember it's important we go back and we always prove our answer. So we recopy the original equation, and we're going to substitute in for b. This time around we're going to substitute in our exact same answer of 7. And 3 times 7 equals 21. 21 equals 21 gives us that true statement. So what that tells us then is we know that in fact our solution here is correct, that this is our solution. Alright, so let's get you practicing one problem on your own here. So go ahead and copy this one down. Be careful, there's -5 there, and give the division property of equality a try. When you start the video back up, you'll have a chance to check your answer. So go ahead and pause it now. Alright, welcome back. Again, I have our answer hidden behind the revealer. We're going to take a look at a piece at a time. So first, let's take a look at solving the equation itself. So I start out, and I can see that -5 is being divided, or excuse me, -5 is being multiplied times x equals 15. Well, we know that the inverse operation of multiplying is division. So that's what tells me that I'm going to need to divide by -5 over here. So I get x all by itself. And remember, if I do that on one side, it's important that we always keep it balanced or equal by doing it on the other. And a positive divided by a negative, remember, always equals a negative. And 15 divided by 5 would give us 3. So what that tells us is that this is our solution. Now we need to double check that solution. So we come over here and we give a check. So remember, it's super important that I recopy the original equation exactly like it started. So -5x equals 15. Then we substitute in that solution that we got over here, and we evaluate both sides. Remember, evaluate just means we follow the order of operations and we do whatever math is necessary. So you can see we did that here. -5 times -3 equals 15. 15 equals 15 is a true statement, so that tells us that we know that this solution's correct. Alright, so the very last thing I want to look at in this video is what if everything's not together in a nice neat package when we start. For example, a problem like this. And so we're going to look at putting it all together, or making sure that we simplify before we solve. So if I want to solve 4x plus 3x equals -28, first I need to simplify each expression. Well, I start out, -28 is simplified, so I can go ahead and recopy that expression exactly like it is. But this side of things, I need to simplify it. Well, 4x's plus 3 more x's means I'm going to say 4 plus 3, or some of us might just jump all the way to 7x, because 4x's plus 3x's mean I have a total of 7x's. Now, I ask myself the big question, what's happening to x? And I can see that it's 7 times x. Well, if I want to get rid of the 7 or to isolate the x by itself, it's important that I'm going to divide by 7 on both sides. So when I divide by 7 on this side, I have a chance to cross the 7 out. And on the other side, negative divided by a positive would give us a negative. 28 divided by 7 would give us 4. So we can see we have a solution of x equals negative 4. Now, before I can go on to any other problems, it's important we go back and check. And this is where I keep emphasizing to you, it's really important you rewrite the original problem exactly how you started. It's common that some people want to jump down here and they want to rewrite something involving 7x equaling negative 28, but we need to remember our original problem was 4x plus 3x equaled negative 28. So now we take our solution, which we got was negative 4. We put that in for x here and for x here, and then we just do it one piece at a time. So we say, okay, working from left to right, 4 times negative 4 is negative 16, plus 3 times negative 4 is negative 12. And at this last point, we need to just put together our like terms or evaluate the left side of things. Negative 16 plus negative 12 would give us negative 28. And negative 28 equals negative 28, which we know that's a true statement, which means that this is our solution. All right. Well, I look forward to seeing you in class tomorrow. Have a wonderful evening.